Okay, hello everybody. So today we're going to continue our discussion on Chapter 8, Section 1, and I'm going to show you some examples of sequences that use some different types of notation, one of which we did talk about in the last video, which is factorial notation, and another one is called summation notation, which we have not discussed yet. So let's get started. It says, write the first 5 terms of the sequence given by, and it gives you the equation, a sub n equals 2 to the n divided by n factorial. And it does note that it would like you to start with your index n to start equaling 0 for our first one. So to do this, we will write a sub 0, and then we will plug in 0 everywhere where you see an n. Now, 2 to the 0 power is 1, and if you recall from the last video, 0 factorial is also 1, so that gives us the number 1. So our sequence starts with the number 1. Then we can go ahead and plug in 1 for the second number of our sequence, and so we'll have 2 to the first, which is 2, divided by 1 factorial. 1 factorial is just 1, and so then that gives us 2. Continuing this pattern, we can do a sub 2 equals 2 to the second over 2 factorial. And 2 to the second gives us 4. 2 factorial is 2 times 1, which is 2. And 4 divided by 2 is 2. So we have the first 3. It does ask for the first 5, so we will plug in 2 more numbers here. A sub 3 is 2 to the third over 3 factorial. And 2 to the third is 2 times 2 times 2, which is 8. And 3 factorial is 3 times 2 times 1, which gives us 6. And so 8/6 can reduce to 4/3. There is our final answer for that one. Now the last one, they asked us for 5, so we're going to do a sub 4. Gives us 2 to the fourth over 4 factorial. 2 to the fourth is actually 2 times 2 times 2 times 2, which is 16. And 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. So we end up with 16 over 24. Now, both of those are divisible by 4, and when you divide both of those numbers by 4, you get 4/6, which are still divisible by 2, and you will get 2/3. So there is our final answer. So you can see this sequence would be 1, 2, 2, 4/3, and then 2/3. Now, the next one I'm going to show you is something called summation notation. And summation notation uses the Greek letter sigma. And this is a sigma right here. Now, I know it looks complicated, but the understanding of what to do here is actually fairly easy. What this does, this is a sequence, and what they want you to do is to add up all of the numbers that you get from the sequence. Now, some of these sequences can be finite or they can be infinite. It really just depends on the indexing on the sigma. So what you see here is we have this sigma, and this tells us that we will be adding each one of our terms up. That's what that means, summation. We're summing the terms together. Now, the next thing you want to look at is what the index is. And this says I is equal to 1, which means we will start with the number 1, and then we will go all the way up to whatever the number is on top. Now, if there's just a variable like you see in this one, then that means it's infinite. But they could have a number such as 10 listed on there, which means we would end up with 1 through a sub 10. So it really just depends on the sequence and the notation as to whether you have an infinite or a finite sequence. So this part specifically is called the lower limit, and this part is called the upper limit. So let's try one of these problems. So they would like us to evaluate the sum or summation from I equals 1 to 5 of 3i. So we need to go ahead and substitute the numbers in from 1 to 5 and get our expressions and then add all of our expressions up. So what this would turn into is we start by putting 1 in, and then we add it to 3 times 2, and then we add it to 3 times 3, plus 3 times 4 plus 3 times 5. And that's it. You can see that the summation says start at 1 and go up to 5. And that's what we did. We would put in 1, 2, 3, 4, and 5. The next step would be to go ahead and multiply all these. So this would be 3, this would be 6, 9, 12, and then 15. And lastly, because we're following PEMDAS, you would add those numbers up. And so when you do that, 15 and 12 is 27, plus 9 is 36, plus another 6 would be 42, plus 3 would be 45. So the total of this summation would be 45. The next one I'm going to show you is a similar problem, but the actual the algebraic expression part of it is a tiny bit more complicated because you can see we have 1 plus k squared. Now our indexing, the lower limit is 3 and the upper limit is 6. So we won't be quite putting as many numbers in, but let's try it here. So we'll start by putting the number 3 in. So we have 1 plus 3 to the second, and then we add that to 1 plus 4 to the second, and then we'll add that to 1 plus 5 to the second. And lastly, the upper limit is 1 plus 6 to the second. And so you can see we get all these numbers. We would need to simplify, or I should say, square them and then add, which is simplifying. But we didn't need to get these numbers figured out first. So 3 squared is 9, plus 1 is 10. 4 squared is 16, plus 1 is 17. 5 squared is 25, plus 1 is 26. And then 6 squared is 36, plus 1 is 37. And the last thing you do is add all of your terms up. So 37 and 26 would be 63. 63 and 17 would be 80. And 80 plus 10 is 90. So the total of this would actually be 90. Now here's another example that is going to combine the last two types of examples we've had, one with factorials and one with summation notation. And so you can see in this particular example, the index starts at 0 and goes all the way up to 8. So we're going to have quite a few numbers to add up here. But if we do that, we will start with 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial. And then we will keep doing that. And there is our last one. Now, to add all of these up, you can see that these will be quite large denominators. Just as an example, if you do 8 factorial. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We get 40,320. So that's going to be a really large number for the denominator of a fraction. And then we would have to get all common denominators in order to add all these up. So this is going to be quite a bit of work if you were to try to do this by hand or even write it out like I showed you there. Now, there's a couple things that we can actually do on our graphing calculator that will make life a lot easier for us. So the first thing that we want to take a look at is you want to go into the home screen. So if you click on math and then you scroll over to probability, what you see right here in number 4 is the factorial key. And so if I wanted to, for example, find 4 factorial, right? So that'd be 4 times 3 times 2 times 1. So 4 times 3 is 12, 12 times 2 is 24. So 4 factorial is 24. Rather than typing 4 times 3 times 2 times 1, we can simply hit 4, click on math, scroll over to probability, and choose the factorial. And when we do that, we get 24. So it saves us from having to type out these very large factorials. For instance, in the problem that we were just working on, having to type out 8 factorial. Now, the next thing that I want to show you is how to do summations. So in order to do summations, we can actually do these types of problems that I was just showing you on your calculator. So rather than having to go ahead and type all this out and try to get a common denominator and add them all up, there's a much faster way to do this on your TI-84 calculators. So what you'll do is you will go ahead, be in the home screen, and type the math key. And when you do type the math key, you want to scroll all the way down to where it says summation. And you got to scroll down. It's actually the 0 option. And you can see it literally says summation. So if you press enter, you can see what happens is we get a sigma put on our home screen that allows us to enter in everything that we had in our problem. So in this case, the index goes from 0 to 8, and it's 1 over I factorial. Now we're not going to use I, we'll use x, but we'll set this to be equal to x. And it starts, the x is going to go from 0 to 8. So you can see I type a 0 there. I can put an 8 there. And then I can simply put 1 divided by x, and then back to our factorial. So we'll hit math again, scroll over to probability, and choose number 4. And once we do that, we have the entire formula in there, just like what we see in front of us. It's 0 to 8 of 1 over I factorial, 0 to 8 of 1 over, and we're going to use x instead of I factorial. Now, the nice thing is, if you hit enter, this thing automatically gives you your number. It's going to be 2.71. So this equals 2.718. And so what we did not have to do was to figure out all these denominators and then get a common denominator and add them all up. It would have been a ton of work to do that when we can just use our calculator to evaluate these summations. So, and what you can see from this particular problem is this problem is very close to the number e. 1 over n factorial is very, very, very close to e. So here are some properties of summations. And what they're showing you here, if you have the summation of a constant, it's just going to be the constant times the upper bound. You don't have to worry about adding them all up. You can simply take whatever the number's on top and multiply it by the constant that you have in front of the summation. This one shows also that if you have a constant times another part of the formula where you actually do need to substitute the index in, you can take that constant and put it on the outside, do the summation of the constant, of the expression, and then go back and multiply by the constant afterwards. These two show you that if you have the summation of two different expressions that are being added, you can take the summation of each expression individually, and the same goes for subtraction as well. Okay, that's what I wanted to show you today. As always, if you have any questions, feel free to email me. Have a great day.